Howdy, have you ever wondered what self-driving, voice assistants, and star tracking have in common? They rely heavily on pattern recognition. My project here today, we use pattern recognition to find north from a picture of the night sky. We first start with a picture of the night sky, and if you've ever taken a picture of stars or the moon in general, you see that there are a lot of blue pixels and red pixels. This is due to atmospheric diffraction and then noise from your camera sensors. The way we get rid of it is through this thing called a convolution matrix. If you're updated on the recent developments in AI, you know convolution matrices are heavily used in this application. But for our purposes, it's very simple. It's like putting a blurry piece of glass on top of your image. The blurriness causes the tiny noises to even out, whereas the bright stars actually shine through. So we're able to get rid of most of the noises and only let the bright pixels come through. So once you only have bright pixels on your picture, we find where these stars are by having a pixel counting algorithm. So in this case, if there are 5 or more bright pixels right next to each other, we call that a star. So these guys were stars, but this guy did not make the cut. Next, once you know where the stars are in your picture, you have to now correlate it with where it is in the night sky. We do this through a method called plate solving. Plate solving involves normalizing or taking any 4 stars from your picture and then normalizing it. So the reason we normalize is because when you take a picture of the night sky from 2 different locations at 2 different times, they look completely different. So you cannot really correlate them with each other. Whereas when you normalize it, it accounts for all these differences by making sure the stars are within or with respect to the longest length. And that allows for it to be of a uniform shape that's the same regardless of what time or what place you take this picture from. So now that we have a shape that's only associated with this set of 4 stars, we can compare it with an existing database of normalized stars that we have. So now the problem becomes a matching whether the square shape fits in the square hole, which is a lot easier. So once that's done, the database gives us the vectors of these, or positions of these stars in terms of right ascension and declination. So on Earth here, we have east to west and north to south. When you're looking up at the stars, it's right ascension and declination. So now that we have the position of stars in our pictures, to find north, we need to know where Polaris is. Polaris, the North Star, is on top of the North Pole. So right ascension really doesn't matter, and all that matters is declination is 90 degrees, which is directly up. So now we know where the Polaris is, and we also know where the stars in our pictures are. So we can simply draw a vector from our stars to where Polaris would be, and we're able to figure out where north is. And if you look at the images on the screen, you can see what we generated, or the arrows, green arrows, pointing to north on the pictures. I'm Bhavesh, and I'm a junior electrical engineering major, and thanks for watching this video.